Let's look at how to draw the structures for compounds in which we have the names given to us. So the first one here is cis 1,2-dimethyl cyclopentane. So the cyclopentane tells us that that is the base name. So cyclopentane, there's how we get started. And then 1,2-dimethyl. So it means we have two methyl groups. The locants are 1 and 2. So you can put your numbers wherever you want. Just make sure that they are right next to each other in a 1-2 relationship. And that's the methyl groups that you have. And the last thing that we have is the cis, okay, over here. So the cis here tells us that the two hydrogens that we have, they are going in the same directions, okay, which means that the methyl groups are also going in the same direction. So what same direction it might be? It doesn't matter whether they are coming out of the plane or they are going behind the plane, okay, so long they're going in the same direction, which means that if you wanted, you can also do this, okay. It will be the same kind of structure because the relationship is still cis and the relationship of the two methyls is still 1,2, okay. So either of the structures is fine. Let's go on to the next one, which is a bicyclic compound, and this is an octane. Bicyclic compounds are really easy to draw once you kind of know what you're doing. So that's what we are here for. So let's start with this. So this is bicyclo 3,2,1 octane. So any kind of a bicyclic compound, it actually has two bridgehead carbons. Okay, so that's how I usually get started, is you draw the bridgehead carbons first. How are they connected? They are connected with 3 carbons, 2 carbons, and 1 carbon. Okay, so 3 carbons. Oops. So let's erase that one, okay, and draw that one again nicely. So 3 carbons, 1, 2, 3. So that's 3 carbons that are joining together. Then we have 2 carbons on the other side. Whichever side, it doesn't matter. Remember, these are the bridging carbons that we are drawing. And then 1 carbon, that is the third bridge. You will always have 3 bridges for any bicyclic compounds, okay? And the dots here, these are the bridgehead carbons. And really, this is it. Okay, so bicyclo 3,2,1 octane. So the 3, 2, and then 1, these are the bridging carbons, and that's it, okay, for the bicyclic compounds. The next one here is a 4-isopropyl 2-methyl octane. So octane now is a straight chain, obviously. So let's go ahead and draw that out. So remember not to count like this, okay? 1, 2, 3, 4, 5, 6, 7, 8. If you do that, that is actually 8 bonds, okay, that you have. So which means 1, 2, 3, 4, 5, 6, 7, 8, 9. So you invariably end up having one more carbon, okay, in there. So this is not a very good way to draw your structures out. So the best way to do that is start with 1 if you want to, okay, like this. Then you count 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is a little bit better way of drawing out long chains. So once you have the 8 carbons, now on the second carbon, you need a methyl group. So you can start wherever you want, left or right, it doesn't matter, just be consistent. So 1, 2, so 2 methyl, and then we have 4-isopropyl. So 1, 2, 3, 4. Okay, and oh, here we go. I don't know how that got erased. And so then on the 4th carbon, this was the 2 carbon. So on the 4th carbon, we have an isopropyl group. So you have to memorize what your isopropyl group and propyl groups and butyl groups are so that you can do all of this. But anyhow, that is the structure of 4-isopropyl 2-methyl octane, and that's that. And then the last one that we have is cyclopentyl cyclopentane. So we have 2 cyclic compounds over here. Cyclopentane is my base. Okay, so here is the base compound. So that is cyclopentane, and attached to that, attached to it is cyclopentyl. Cyclopentyl means another cyclopentane. Okay, so it doesn't really matter which one is the base over here because all they're both the same. Okay, so the TYL or the YL here tells me that it is attached to something. Okay, so that's how you do the last one here.